Good morning, everyone. My name is Rachel, and I'll be your webinar moderator today. Today's webinar is sponsored by NatRoad's Platinum partner, NTI, National Transport Insurance. NTI is Australia's #1 truck insurer, delivering premium insurance solutions to single commercial vehicle operators, fleet owners, and off-road operators. Today's webinar is being presented by the Artsa Institute, leaders in gathering and analysing information on the heavy vehicle transport industry in Australia. We'll have two speakers today discussing the causes of truck fires and how to minimise risks. Martin Toomey will be first up. He is the current chair of the Artsa Institute and CEO of Transport Equipment Australia, which creates tailored engineering solutions for axles, rotors, ADR-approved braking kits, air and spring suspensions, and in-house caliper remanufacturing and exchange programs. Then we'll have Dr. Peter Hart. He is the principal of the Hartwood Consulting Proprietary Limited. He has conducted or supervised more than 2,000 forensic investigations over the past 25 years. This experience has included the investigation of approximately 100 vehicle fires. Like always, we'd love to hear from you during today's presentation. If you have a question, please feel free to type in your questions in the Q&A section at the bottom of your screen. You may send in your questions at any time during the presentation, and we'll be answering questions at the end of the session. Okay, so let's kick things off by starting with Martin Toomey. Martin, over to you.
Thank you very much indeed, Rachel, for that great introduction, and welcome everybody to this NatRoads webinar. And thank you very much for NatRoads for allowing Artsa to present some of our research findings today. And also, of course, great thanks to NTI, our webinar sponsor, for their continuous support to the industry. It is much needed and much appreciated. A little bit about the Artsa Institute. Formerly, Artsa, which stands for the Australian Road Transport Suppliers Association, was very much seen as a technical working group that consulted on advocacy change programs with government and regulators. It's morphed recently throughout this sort of pandemic period. We've gone through quite a strategic shift. We're now focusing primarily on independent collaborative research projects, and the project that we'll be presenting today on truck fires is a very good example of the sort of the work that the Artsa Institute is undertaking. We see ourselves as a leader in gathering and analysing information on the heavy vehicle transport industry. And while there's lots of data available out there, the key is turning that data into something usable. And I'd certainly like to think that Artsa is one of the best industry think tanks positioning itself today, in our industry at least, to take data and turn it into very, very useful insights. We also work with Austroads, with the NEVDIS data, which is the registration data collected across the individual states. And from that data, we can put together customized reports on the status of the truck and trailer fleet in Australia. But look a little bit more about today's very important topic on the causation of fires. This project came about really because of some collaborative partners. Most importantly, the Truck Industry Council with Chris Luce, who is the technical officer of TIC. Chris and his contribution has been absolutely invaluable to the Truck Fires project, as well as the National Bulk Tankers Association, who helped us to get funding from the regulator to allow us to produce this project. So we have to acknowledge our key partners in this as well. But look, the main contributor has been Dr. Peter Hart, and it's Dr. Peter Hart that I'll be handing you over to very shortly to present the overview of the Truck Fires project. And if I could just say, please reach out to Artsa if you'd like to get a bit more of a deep dive than the webinar allows today, because we are literally just scraping the surface today on the causation of fires and the approach that Artsa has taken to this topic. But if you would like to learn more about it, then please do reach out to us, and we'd be more than happy to share more with you. So with no further ado, I'd like to hand you over to Dr. Peter Hart. Peter, good morning.
Good morning. Thank you, Martin. And thanks to NetRoads for this opportunity. There's nothing worse than seeing a beautiful piece of machinery burn to the ground at the side of a road. It's a distressing sight for the community, but it's devastating usually for the operator of the vehicle. And anything we as an industry can do to reduce the risks, we should be doing. So I'm now going to have a presentation that I'd like to go through, and I'm going to attempt to get share screen going. So let's
okay.
see over here.
I will end my slideshow at this point.
Yes. Thanks, Martin. So bear with me, please. How am I going, Rachel? Can you see a screen?
Very good, Peter. I can see it.
Yeah. Yep. Okay. So, causes and prevention of vehicle fires. Now, the introduction that's been given so far talked about truck fires, but we shouldn't forget our good mates, the trailers, because they are also involved and quite often implicated, perhaps in a third of heavy vehicle fires as a talking point. I mentioned a moment ago the distressing scene of a truck burning. This happened in the Adelaide Hills a while ago. You'll notice that the passenger and the driver have nothing other than to do than call emergency and wait. In this case, because the truck fire has started in the engine compartment, and there's a bit of a telltale sign there that there's drop-down fire spread to the ground. You can see some leaves burning underneath the engine compartment on the left-hand side, which just happens to be the starter motor side, by the way. I'm going to start with my ordering of the common causes of fires on trucks, and then in a moment trailers, and then I'm going to give some examples and discuss some fine details. So I'm starting here with a high overview of things as I see it. My ordering of common causes of fires on trucks, and I've underlined trucks. In a moment, I'm going to talk about trailers. Arcs on the starter or battery cables, alternator, cabin, and trailer supply cables. That is electrical arcs on main cables. Number one. 2, fuel line rubs or failures that result in leak spray of fuel onto the exhaust. They're also reasonably common, unfortunately. Lubrication or oil line failures due to lines being too near to the exhaust pipe. They come up pretty frequently. Turbocharger oil seal failures. And then we get to number 5, flammable material resting against the turbocharger. Number 6, aftermarket fuse and installation problems. That is modifications to the electrical system after the OEM's build. And number 7, bearing failures leading to dragging brakes and hence tyre fires. That's my number 7. Trucks higher up the list of trailers. Let's talk about trailers. Common cause of trailers. My number, wheel bearing failures or oil seal failures, but let's say hub failures that result in dragging drum brakes. Then we've got dragging brakes damage to the pneumatic spring brake system. So this is an air system problem, usually with spring brakes. Number 3, tyres catching fire because they're flat or poorly inflated or rubbing on mudguard surfaces. And number 4, friction rub on mezzanine support bracket has been an issue on trailers over the last couple of years. So you'll note that I'm saying that You don't normally see fires from electrical problems on trailers, whereas we do see them on trucks. And the other side of the story is that the problems are usually wheel end problems on the trailer, whereas they're not usually wheel end problems on the truck. And to some extent, this is because the trailer, the driver is aware of what's going on the truck and is more tuned into the wheel ends than he or she is on the trailer. So that's an observation. You'll often see in the press distressing scenes like this. The M7 has been closed because of a truck fire, or the Monash has been closed, etc. These incidents are expensive incidents, not only for the operator, but also for the community and for the emergency services people. Some of the toll road operators talk about trying to recoup lost toll revenue because the toll road has been closed. So it's a very significant risk. And I say again, anything we can do to reduce that risk, then we're doing a service for everybody. I want to talk about rubs on main electrical cables. Here's an example of a main alternator cable, which is actually the cable on the right side, lower right side, which has been rubbing on a stud that comes off the side of an engine. The stud was there to take a plastic cover, but the plastic cover wasn't necessary. Nonetheless, we ended up with an alternator cable rubbing. The split conduit in this case opened up and actually grabbed onto the stud so that the cable was rubbing for a continuing period. A sparking occurred. This particular cable, the alternator cable in this truck, has no circuit breaker protection because it's taken off the starter motor terminal, and starter motors do not have circuit breaker protection. This is a fundamental point. It means that we rely on mechanical protection of these cables. If the reason for no circuit breaker is the starter motor might draw, say, 1500 amps on a 12-volt truck, and by the time you put a 2000 amp circuit breaker into that line, you're not really protecting against a casual rub of the insulation. Such a rub would draw a lot less current than 2000 amps, so there's hardly any point in having a circuit breaker in there. We must rely upon good insulation, good mechanical protection of main cables. Sorry, there we go. Here's the one. In the battery box, the cable had been repositioned and put on top of a threaded bolt that was part of the original design. This was a very convenient to get that cable out of the way. But as mentioned, no circuit breaker on that cable, and consequently no protection against rasping of the cable. It's pretty obvious what happened there. The conduit also provided fuel for this fire. This is, that last one was, I think, due to a maintenance person moving a cable. This one's due to an OEM installation. Main starter motor cable run through a P-clamp, and it's been rubbing on the metal of the P-clamp. The rubber insert is not there. We've ended up with a cutting of the insulation, a short circuit leading to fire. The driver in this case, and in other cases I've investigated, was unaware of this rub until smoke and then flame appeared. The truck would operate apparently normally, although quite often, if this happens at night, the driver will see flickering headlights or maybe even flickering gauges because of the effect of the rub, and that's a telltale sign that should not be ignored. The problem, however, is that the driver gets very little forward warning of this situation. This is an interesting one. The fire appears to have occurred up under the windscreen where there is a lot of electrical circuitry installed. You can see that the fire damage is clearly biased up the top. There's very little down the bottom. You can see blue polymer hoses that have survived. You can see a fuel filter damaged but not destroyed. So it's pretty obvious that it occurred up the top. In fact, it occurred because the return cable had been left off the starter motor when the starter motor was changed. And the current was, the return current was coming back through a minor link between the starter motor and the chassis and not through the major link that goes back to the battery. And eventually that minor link got too hot and caught fire. So the fire started down low and it spread up to the top because it burnt on the conduits. Most electrical cables are protected by a split plastic conduit, and the conduit burns like buggery. That is a fundamental failing of many heavy vehicles. The conduit provides the fuel in case of a rub on the cable. The cable itself has flame retardant insulation on it and is hard to get going, but the conduit burns freely, and poor quality conduits, which are on many vehicles, are a factor in fires and getting heavy vehicle fires going. I can't get the design rules changed because it's not seen as important enough, but I'm trying to make the industry aware that conduits with flame retardant properties are important to prevent electrical fires. Faults on minor electrical cables. In this case, a fire has occurred in the fuse box of a well-known branded truck, but it wasn't the truck's problem. It was an aftermarket installation, and the item 3 that's highlighted there is actually a fuse holder. The fuse holder has a rubber structure. It's a fairly well-known beast. You'll find it in catalogues, and it overheated, and in this case, in my opinion, the rubber caught fire and the fire spread from there. So the issue at hand here is actually choosing an appropriate part to provide the protection. In this case, this is actually a flashing amber light on the top, a beacon light on the top of a garbage truck, and the installer of the light has decided to use a return path via a rubber bush. You can see that there's a rubber washer underneath. This has been put in for vibration reduction. And the problem, however, is that the circuit does not have a reliable connection. When the truck's going along the road and the light's bouncing up and down, the connection pressure goes up and down. The normal current makes a hot joint. Eventually, in this case, the light caught fire. So this is a fairly basic problem. Bad terminal connections often cause fires. They get hot. It can take a long time for it to get hot enough to cause the insulation of the conduit to catch fire. But in many cases, it'll eventually get there. So just summing up on the light current stuff, poor quality connections cause hot terminals. Aftermarket suppliers often overrate electrical terminals, in my opinion. You should halve the published rating of electrical components if it's for use on heavy vehicles. So to illustrate that comment, if you've got a 30 amp cube relay, you actually should put only 15 amps through it, and then it'll last the life of the truck. Quite often I see bad connections purely because, well, hot connections because too much current's being put through things. My number 3 point here is a lack of fire retardancy standards for aftermarket equipment, and I should also add really OEM equipment. We should have flame retardant requirements on conduits, for example. We don't have flame retardant requirements for fuse holders, etc. So we could do a lot better with standards here. Poorly chosen electrical protection on add-on wiring. The fuse holder that I showed before, which has a quarter blade or 6mm terminals, is rated for 50 amps max. However, the same manufacturer or same supplier will sell you a 100 amp fuse that will fit nicely into it. And I've seen many 100 amp fuses pushed into nominal 50 amp fuse holders, which I say are only good for 25 amps on trucks. So you can see the problem here. Poor quality terminal connections generally. They get loose, dust is a factor. They need to be checked every now and again. So this is the old sensible advice. Take a slow look at your equipment when it's in the service shop and just check that things look as though they're good, not deteriorating. And point number 6, the wire gauge should be chosen for mechanical and heat performance. Whilst it's carrying electricity, it's also important that it's strong enough and that it takes heat out of the terminals. And to do that, it needs to be a generous wire gauge. Right, fuel and oil line fires. I made the comment there, only the exhaust and the turbocharger are hot enough to ignite oil or diesel. Oil or diesel will not be ignited on the engine block or anywhere else for that matter. It's the exhaust system that is the vulnerability. And of course, the fuel system is always put on the other side to the exhaust system for that reason. This particular fire started outside the cabin on the right-hand side, just in front of axle 2. And it happened because the fuel lines, the normal fuel lines from the tank, which are being run in a spiral conduit to provide mechanical protection, actually rubbed on an edge. You can sort of see an edge there, a structural bracket, and the polyamide fuel tubes are actually, one of them was sitting on that edge through a split in the conduit. And there was a leak of fuel. And that leak of fuel, I haven't got the photo here, that leak of fuel got onto the exhaust pipe, which was running fairly close inside the rail at the bottom. The fire occurred on the road and it was due to a spray of fuel. The driver knew nothing about it until the fire occurred. It was probably on the return line, fuel line. Here's a common problem on a particular type of engine, cracked high pressure injection tubes. You can see the crack in a tube there with the arrow, and it's very hard to see. It is due to vibration damage over a long period of time, and it produces an aerosol of fuel in the air. And that aerosol will eventually get over to the, or in some cases will get over to the exhaust side, where it will contact, say, the turbocharger bowl, and next thing you know, you've got an explosion in air, you've got a serious fire. And the driver will be aware of it at the last moment, it'll go bang, and there may well be flame coming out from under the bonnet if it's a bonneted truck, and that flame might cause the driver loss of vision at night. So it's a very serious situation. This particular engine is on recall because of this tube problem. It's to do with vibration damping. Here's another one to do with oil on hot exhaust. This particular engine had a mechanical failure. You can see the top of the engine has cracked. You can see a rocker shaft there. And you can also make out that the turbocharger is very close just behind. So engine failure, oil pushed out the top, gets onto the turbocharger bowl, fire starts. So some comments about fuel systems. Low pressure fuel hoses too close to exhausts. Minimum spacing, in my view, should be 250 millimetres. You can make it closer if you put a shield in. I criticise some of the OEM manufacturers' spacings in this context. Low pressure fuel lines sitting on sharp edges, particularly above exhausts, eventually they're going to cut through and there'll be a fuel spray. High pressure fuel line cracks due to vibrations, just discussed that, and failure spray zones oriented towards exhaust pipes. You'll often see both fuel lines and hydraulic lines that are put in a place where failure would cause inevitable fire. They're simply pointing, the failure hose would be pointing at the exhaust. The spray is going to hit the exhaust. It's a very common problem, particularly on machines, hydraulic machines. The hydraulic system is installed without due regard to the location of the exhaust pipe. Turbochargers. Turbocharger failures occur because the bearings fail in the centre of the turbocharger, and this is a cutaway section showing the oil seals, arrow to an oil seal. You can see the two sintered bearings there. Turbochargers have oil-cooled bearings. The oil is pumped, engine oil is pumped through, cools the bearings. If you have a seal problem, particularly on the hot side, then you'll end up with a fire in the exhaust. Mostly that fire doesn't cause trouble because the exhaust's used to having high temperatures, but occasionally the low pressure, or sorry, the cold side, the boost side seal will fail, and this fire will also get into the boost side. If it gets into the boost side, it will quickly burn through either an aluminium pipe or a rubber elbow, and it'll get into the engine. So the message here really is don't keep your turbocharger serviced. Don't just run it till it breaks, because that runs a significant risk of end-of-life failure being exhaust fire. So here's some comments on turbochargers. Intercooler air links result in low boost. Controllers respond by over-fueling. That makes the exhaust hot, and the turbocharger won't like it. LPG gas top-up fueling via the air intake probably cause the exhaust temperature to be too high. I've seen a couple of those cause failures of turbochargers. And drivers usually should say usually sense when the turbo performance is low, but drive on at your own risk. If you think you can keep driving because the turbo will be okay, you'll probably find it won't. Wheel bearing failures. This fire closed one side of the M2 in Sydney during the morning peak, and here is the problem. This is the particular trailer. You can see that the first axle on the left side has a bearing failure. You can make out the remains of the inner bearing. The outer bearing is actually completely cactus. It's just welded up. The bearings have failed. The brake drums have rubbed on the brakes because the axle is no longer centered. You can make out the wear on the brake drum. You can see it's white and it's cracked away. This has resulted in the brake drum immediately above becoming very hot. The heat from the brake drum has radiated onto the aluminium wheel. This used to have an aluminium wheel there. The aluminium wheel is a good conductor of heat, so the bead of the tyre is heated by that aluminium wheel rim, and eventually the tyre catches fire, in which case the fire spreads upwards and to other wheels. In this particular instance, the bearings were new. They'd been installed a couple of weeks beforehand. These are bearings off the other end of that axle that caught fire. You can see that the grease is distressed. it's carbonised, the bearing's been running hot. This fire was due to excessive preload in the workshop. Mechanics have a hard job at getting the preload right, and there's definitely a case for having some measurement equipment to help them. I make the point that some of the unitized bearings, I haven't seen a fire due to a unitized bearing. I've seen fires caused by the failure of the outer bearings on single bearing installation. So I think that the performance of unitized bearings is better. This is a diagram from Timken, and it's showing how vulnerable bearing setups are. It's showing here bearing life versus preload. And you can see a preload of about 0.1 of a millimetre, 1.15 of a millimetre is excessive. This bearing is likely to fail because it's too tight. And failure probably means, or could mean, wheel end fire. So getting the preload right is really important, and it's a skill that good mechanics have. I feel for mechanics, this is a very difficult task. Dragging brakes. Dragging brakes can, as I've just described, come from bearing failure, but they can also come from failures in the brake system. The shoes in this case have blued because they're so hot. Some points. Fires due to dragging spring brakes mainly occur on drum brakes. The aluminium wheels transmit the heat better than steel rims. Dragging brakes can cause the wheel seals to fail on disc brakes. So if you've got a disc brake, you're more likely to get the inner wheel seal failing, which might mean that oil comes out and gets onto your brake, and so you have a relatively minor fire on the inside of the wheels, usually minor. Drum brakes seem to be much more vulnerable to wheel end fires. Low slung brake actuators and hoses are vulnerable to road strike. This is particularly true on trailers. There are some unbelievably low slung brake actuators that will be hit in the surface of the trailer, and that striking by road debris or throwing up stones or whatever is likely to cause the spring brake actuator to fail. And it might also, of course, take the hoses off the spring brake actuator, which is also going to cause trouble. So there's a real problem, in my view, of with trailer actuators, particularly on disc brakes, which are put down low and they're quite vulnerable. I make the point that carbon particles from oil are generated in unloader type air compressors on long journeys. These carbon particles are blown through the air system. They might get, some of them will get through the filters. They'll clog up the air valves, and in some cases they will cause blockage or malfunction of spring brake relay valves. So the air system needs to be periodically maintained to get rid of that gunk. In my opinion, dragging service brakes rarely occur. It's usually the spring brakes that cause the trouble. Tyre rubs. In this case, this is actually a car carrier. It's got a metal guard because the precious cargo of cars should be protected against road debris. In this case, the suspension, the air suspension failed, and the tyre rubbed on the mudguard, and eventually the tyre caught fire. Here's really just a view of an air suspension. I'm just making the point that if there's a problem in the air suspension, which can happen very, very easily because the hoses, the tubes that run to these airbags are not particularly well protected. If you get a crack in one, an air leak, you can have a deflated airbag system not fully deflated, but enough to cause tyre rubs. In my experience, the problem is with hard mudguards, not with soft mudguards like plastic mudguards. It's actually tyres rubbing on hard things. And to illustrate that point, this is the result of a tyre rub on a heavy duty mudguard. The mudguard was a thick rubber conveyor belt type mudguard, and the bracket that held the mudguard up had failed. It was drooping down. Consequently, the tyre was able to rub on this rubber mudguard, and the friction caused excessive heat. Eventually, the rubber mudguard caught fire. So, some final comments there. Tyre fires mainly occur on trailers and not trucks, because usually the drivers can see developing signs on the truck. Not always, but usually. Principal cause is deflated air suspensions. Secondary cause is deflated inner tyre causing a rub. Driving with deflated tyres can result in pyrolysis of the rubber, that is, internal heating of the rubber on the sidewalls, and it's usually under control whilst the vehicle is moving. Not always. Eventually it'll get hot, very hot, and you might have a fire, but often the wind that's blowing around the tyres keeps them cool enough so they don't catch fire. The problem then occurs when the truck stops, because the tyres are now so hot that they can catch fire without the cooling effect of the wind. And to make the point at the bottom, the only way to put out a tyre fire is with water. You can use a powder extinguisher on it if you like, but it does not take the heat out of the wheel end. And I'm on a bit of a campaign with fuel tankers. I think fuel tankers should carry routinely 9-kilogram water extinguishers so that the driver has got some chance of attacking a wheel end fire. And that's all I've got in the time available. Thank you for listening. Happy to answer any questions.
Thank you, Dr. Peter Hart. We haven't had any questions come through during the webinar. So unless
I'm having trouble hearing.
Oh, sorry. Can people hear
We
me?
got.
Oh, sorry, can you hear me now?
Yes, that's good. Thank you.
Sorry, that's all right. Yes, so sorry. Thank you, Dr. Peter Hart. We haven't had any questions submitted during the webinar. So if nobody has any questions now, we'll wrap up there. However, if anyone watching does have any questions, you are free to email them through to info@natroad.com.au, and we'll definitely get you answers to those questions. But for now, thank you, Peter, thank you, Martin, and thank you everyone at the Artsa Institute. And thank you everyone for attending today's webinar. Today's webinar will be uploaded to the website and to our YouTube channel. So once again, thank you for joining us today. We hope you have a great day.